So for the exam, you will need to upload your work to show your work. And I am looking for a certain style or quality to be able to grade it efficiently and for you to learn how to communicate mathematically. A lot of you had shown your work on the first quiz and had done a good job on it, so I'm pretty happy. But I still want to give you an example or some examples of what work I'm looking for some of the problems that you could see on the exam. So that's what this video is about. These are just the practice questions for the exam. You can go ahead and take a look at this particular question. This question describes a scenario where Wendy's car is stuck in the mud and Karen and Marco are coming to help. They're using two sources of forces to pull the truck out of the mud. One is going to be horizontal. This is done by the tow system they set up. The other one is, I guess, Karen and Marco pushing from back at a slightly upward angle. This diagram represents both forces as vectors, and we're asked to find out what the combined force is or resulting force is. We're also asked to compute its magnitude, so of that resulting force vector, and the angle above the x-axis or the horizon of the resulting force. I'm looking for a sketch of with labeled forces, which is mostly given to you in this problem. Formulas used to find the answers, which in this case probably means something like using sine and cosine rules to write your forces in component form if you like. But also the magnitude formula, what you're plugging in there to calculate it, and also a formula to find the angle of the resulting force. We have the two forces working on the truck, and we're looking for the resulting vector. I use the parallelogram law to be able to figure out what that force vector looks like, the resulting vector. I've labeled it as the resultant force. And notice that my freehand drawing isn't perfect, but it's a pretty good cartoon sketch and things are labeled so we at least know what it's talking about in the context of the problem. I'm going to shy away from the purple color, or whatever that color is, the pink, because it's easier to see the red for the rest of the problem. I also label this as the first question, and my first work is going to base on part A of this question. I will use the fact that my answer is in component form, and if I can write each of these two vectors in component form, the resultant force is just the sum of the component forms. Notice I also labeled the edge vectors that I want to combine, and I'm labeling over here as FTs being the force from the tow strap pulling Wendy's truck, that's the bottom one over here, and FMK is the force from Marco and Karen pushing. This diagram does not give those forces in component form, so I have to find them. For the force from the tow strap, picture-wise, it looks pretty clear that it's only along the horizontal axis, which is pretty much in component form as 344 pounds in the horizontal direction to the right and 0 in the XY direction. I didn't have to do much work. Next up, I project this particular force in both the X direction and the Y direction. And I remember that on a two-dimensional plane, I can make a right triangle with the hypotenuse being the 105 pounds of force along the vector. And if I want to find out what the leg along the x-axis is, that is the same thing as the hypotenuse times the cosine of the angle adjacent. And if I want to find out what the amount of force in the y direction is, that's the same thing as the hypotenuse times the sine of the angle opposite. You don't have to draw out what I just said about sines and cosines, you do have to know it. I can assume that you know it if you write this down though. So the resultant force is the sum of the two other force vectors, that's parallelogram law, which is up here, but in component form you're just adding the x to the x and the y to the y. The x to the x component and the y component to the y component. It looks like for this particular problem they let you put in cosine or sine. They just don't want you to put in the degree symbol when you enter it into the answer box. So this can give you a high level of precision when you put in the answer box. For me though, all you need to do to show me work is basically this. This is a complete set of work for part A of problem 1. Part B is just asking for the magnitude of the resultant force vector. For something as simple as just using the magnitude, I want to see that you're finding the magnitude of the right vector, that you know what to substitute into the magnitude formula, and that you understand how your calculator works so you can get the right settings to make sure that your cosine and sine, if you're plugging degrees, you change it to degrees, and that you have the order of operations with your substitution in correctly for computing a number. For the last part, I am going to go ahead and label a new variable because we're asked to find the angle of the force vector above the positive x-axis. So I labeled it here so that you can see what that angle should look like on the diagram. And I also labeled the angle over here so you know what alpha means in this case. You don't have to call it alpha, you just have to tell me what it is. And I write down the formula I'm using to find the answer in this case. It's helpful to remember that I still have a right triangle with the hypotenuse being this long resultant force vector. So I can use the length of the x component and the length of the y component and take the ratio of the two to give, that's the same thing as the tangent of the angle, and so I use the inverse tangent formula to figure out what that angle is. And I just want to see you what you substitute for the y component and the x component to make sure it's correct, and then make sure that your settings for your calculator is 2 degrees on this problem because the problem asks for the answer in degrees.